Assalamu alaikum ma'am. Good morning. Today I'll be presenting my reviews on two research paper that uses machine learning in two different domains. The first paper focuses on cardiovascular disease prediction using machine learning, and the second paper analyzes sentiment from text data. Both of the papers demonstrate how machine learning can extract actionable insights from raw data. These are the contents we'll be covering in our presentation. For both of the papers, we will cover some common contents, and after that, uh, I will be covering combined insights, final remarks, and references. Uh, After I am done with the presentation, I will be answering some common questions. The paper is named as Analysis and Prediction of Cardiovascular Disease Using Machine Learning Classifiers, written by Kamal Kumar Nepa and others. Cardiovascular system contains heart, blood vessels, and the blood itself. Around the globe, every year, 19 to 20 million people dies because of cardiovascular disease. So it has been a leading cause of mortality worldwide, and early detection is crucial. Machine learning models can assist clinicals by identifying high risk patients using routine clinical features. Uh, and the study evaluates multiple classifiers to determine practical, interpretable, and deployable solutions. Moving on to the next part, what motivated them was reduced preventable mortality by earlier risk stratification with low cost data. Their objectives were compare popular machine learning classifiers on a cardiovascular disease dataset, assesses pre-processing choices, evaluation methodologies, and model explainability. Provide deployment aware recommendations, interpretability, and calibrations. If we are given a set of clinical features that includes age, sex, blood pressure, cholesterol, if the patient smokes or not, if the patient has diabetes or not, and we are said to build a classifier that predicts presence or absence of cardiovascular disease. We might face some key challenges like class imbalance, missing values, covariate shift across populations, and clinical interpretability. We have some desires for our models: uh, high recall for positive calls, class, calibrated probabilities, and interpretable feature importance. The dataset they have used is Cleveland heart disease dataset. They have collected around 300 samples. Although they have 14 attributes in their paper, as I have read, uh, this table contains only 10 and consists of numerical and nominal data type, value type. Nominal value type is a qualitative value type. So these are the steps how they pre-processed the data. They first handled missing values and labeled encoded the categorical variables. They have normalized the data and splitted the train and test into 80 and 20% respectively. They have used some popular or classic machine learning models: the k nearest neighbors, random forest, decision tree, support vector machine SVM, and logistic regression. If I have to say something about these models, I would say uh, let's just explain the models one by one. The k nearest neighbor is An algorithm is a lazy algorithm that finds the k most similar most the k most similar historical historical data, and based on the majority vote, it predicts the patient might have disease or not. In order to understand random forest, we first have to understand the decision tree. The decision tree is a normal tree that uses for decision making. Uh, if this condition meet, we will go to we'll go to we'll take up. It's a conditional tree in a single word. It's a conditional tree. I'm really sorry for the interruption. A decision tree is a data structure that we have seen earlier. A random forest consists of many decision trees. Support vector machine SVM is SVM is uh, SVM draws hyperplane based on the input data. If the input data is multidimensional, it creates a hyperplane and differentiate the data across the dimensions. Logistic regression is logistic regression. Okay, we are moving on to the next part. They have evaluated uh, evaluated the results primarily based on the accuracy, and they splitted the training and testing data to 80 and 20% respectively. They haven't used any hyperparameter tuning, and no cross validation was found. The result shows that the random forest had the best performance. Uh, after that, the decision tree and the logistic no after that the support vector machine did the best performance, and after that the decision tree and the logistic regression had some similar performance. uh, Compared to them, the KNN algorithm performed too poorly. So in my critical analysis, I have found some limitations of the paper. That is, they had no external validation, no cross validation, no hyperparameter optimization. The dataset was too small, and no fairness or demographic analysis were found. So the conclusion shows the random forest achieved highest accuracy, like 85%, and the paper demonstrates feasibility but lacks modern machine learning rigor. Better evaluation and validation would significantly improve the reliability of the paper. So we are now moving to the next paper. The second paper is named as Comparative Study of Machine Learning Techniques in Sentimental Analysis, written by Anisha Rodriguez and others. The paper focuses on comparison of classical and machine learning or deep learning based techniques for text sentiment classifications. Sentiment analysis extracts opinions and emotions from text, which is very critical for business, social media monitoring, and public opinion research. Um, the rapid model advancements from bag of words to classical classifiers to transformers, and the paper compares multiple pipelines and demonstrates trade-offs between performance and complexity. Uh, what I have found that motivated them to rewrite the paper was businesses need automated opinion mining. Text data is massive and grows every second. Finding the most efficient and accurate machine learning classifier for sentiment analysis. Now, if we are given text sample labeled with sentiment classes positive, negative, neutral, or multi-class, and we will build a classifier that generalizes across domains. The key problem was domain shift, like Twitter versus reviews versus other sources, detecting sarcasm, negation handling, class imbalance, and limited label data. Their primary goal was to train machine learning models to classify unseen data, uh, take unseen text data from various sources, and the challenges they faced were slangs, emojis, noisy text, sarcasm, negations, and many others. Dataset they have collected tweets from Twitter. Have collected over 9,000 tweets and labeled them as positive and negative. So this is how they have pre-processed the data. They first have used tokenization, stopper removal, stemming, removal of URLs and special characters. TF IDF. It is an para. It's a method to convert text into numerical feature vectors. Uh, I have already described here what every steps mean. Tokenization means if we are given a sentence, we will split it into words, individual words or tokens. Stop word like common English stop words like is, the, and. If we found these words, we will remove them. Stemming, reducing words to their root form, and we will remove URLs and special characters. Uh, they have used only two feature extraction here. One is the bag of words, and second one is TF-IDF methodology. The machine learning models they used are naive Bayes theorem, SVM, decision trees, and KNN. I have already explained what SVM, decision trees, and KNN are. And the naive Bayes uses the uh, regular Bayes theorem that we have studied earlier. If I have to again explain the decision trees, it's a tree-based structure, data structure that uses decisions to predict the outcome or output. Now let's move on to the next slide. In their paper, they have taken the accuracy as the main evaluation metric. The confusion matrix was internally computed. They haven't used any F1 score, precision, or recalls. They also didn't use cross validation and no hypermeter tuning. The Nevias theorem shows the best results, which have an accuracy of 82%. And after that, the SBM performed really well, which have an accuracy of 79%. And after that, the decision tree and the KNN. Here is a screenshot of their results from the paper itself. So error analysis, these are the error I have found in the paper, which are sarcasm and irony commonly misclassified, domain specific vocabulary causes drops in performance, class imbalance leads to poor minority class recall. My analysis shows they have no deep learning comparison, no domain adaptation, no analysis of sarcasm or misclassifications, no external benchmark datasets, very simple pre-processing steps. Conclusion: Bayes' theorem performed really well among all other among all the machine learning models. The paper provides a simple but incomplete comparison. Modern NLP methods would likely achieve far higher accuracy. So these are my cross-paper insights that are classical ML performs strongly with clean pre-processing. Lack of cross-validation reduces reliability, feature engineering, and explainability are missing. No external validation in either of this study. Both can be improved significantly with modern ML and NLP tools or NLP tools methods. Both papers demonstrate strong foundational ML application, however, both lacks rigor by modern research standards. This is my final remark. Here are the references from the two paper. Thank you, man.